Okay, so I think I have the last session before the coffee break, so I will try to make this as fast as possible. Hi everyone, my name is István Ráth. I'm from Hungary. I work for a company called InQuery Labs, and I'm going to talk about the Eclipse VIATRA framework, which is, as you will see, a very interesting framework in Eclipse modeling. So just to try to explain this to you as quickly as possible and jump right into the middle of it, VIATRA is basically a modeling technology that is primarily targeting advanced modeling tools and scenarios which are very common in critical systems engineering, systems modeling, automotive software engineering, and related fields. And basically, in all of these fields, you have modeling tools, commercial products or open source products, some of which are well known in the Eclipse modeling world, some of which are not that well known, perhaps, here in this community. But anyway, what's common in all of these technologies is that they use a lot of fundamental tool features, which are essential for actually making the tool work and to make the tool work in an efficient way. So basically, VIATRA is an enabling technology. Its audience is the tool developers, so not really the end users, but the tool developers. And it provides two major functionalities: model queries and model transformations. And we designed this technology in a way so that it's deeply integrated with other parts of the stack, including obviously Java as the fundamental technology underneath the hood. But you will see that for the model transformation part, we heavily rely on Xtend and build on top of the functionality. And then the very core, VIATRA itself, is a reactive query and transformation engine, and I will try to explain to you in the following 10 minutes what I mean by this. So first, I would like to talk about VIATRA Query, because this was the first thing that we've been working on for many years, in fact, and this is where the whole development originally started. So the original motivation for us to start working on this technology comes from, in fact, the automotive software engineering domain. How many of you have heard about AUTOSAR? Hands up. Okay, so quite a lot. I don't need to introduce AUTOSAR to you guys then. In a way, AUTOSAR is it's a widely used modeling standard for in the automotive world, and one of the common themes that is found in basically all of the AUTOSAR-based tools today is the capability of design rule validation, which is basically checking the model against design rules which are somehow corresponding either to things which are described in the standard, or maybe even in-house best practices that are specific to a company. And what we've observed was that in many cases checking the model against such design rules basically boils down to a model query problem, right? So you can formulate such a rule as a query to look for those parts of the model which have a violation. And obviously the challenge here comes from basically two factors. First of all, the rules can be very complex or non-trivial in many cases. And second of all, especially nowadays, the models tend to be large. So models that contain more than 1 million elements are not, a rarity anymore these days, but it's getting more and more of a common theme. So what I mean by a complex rule is basically something like this, where it's much more than just a typical query, right? That you would say that we are looking for something which has got the attribute value less than 5. What I mean by a complex rule is something which we call a graph pattern, which involves several model elements which have to be connected to each other in some way, or do not have to be connected in case of a negative condition. And the rules can also contain many more traditional things such as attribute constraints, etc., etc. So this is basically the fundamental problem that VIATRA Query was originally meant to address. The way these kinds of validation rules are typically implemented in tools using an imperative language such as Java is basically writing a nested for loop. So you iterate over the contents of your model, and at each step you include some checks, do some navigation steps using getters, etc., etc. And while this may seem simple, obviously it's not that simple if you have a complex rule, and what is even less obvious is how to write a code like this, which will scale nicely when the model is really large. Because as you can see, writing nested loops quickly adds up on the computational impact of the whole problem. So in order to avoid this, VIATRA uses a declarative language which allows the developer to concentrate more on the specification of the result rather than the actual way of how that result should be computed. This is basically the fundamental idea of all declarative query languages such as SQL, because underneath the hood there is a query engine which does deep optimization in order to make sure that the query can be evaluated as fast as possible, and this is in fact what we have here as well. So this is our query language, which is called VQL. Conceptually, it's based on graph patterns. So if you've learned about Sparkle, for example, or used some other languages such as Cypher, which is a more recent one, it's basically the same fundamental idea. But what's very powerful about this language is that you can do things like this. So you can actually compress a navigation along 3 different edges into just one statement, telling that the result should incorporate such a navigation step, and what will happen in the background will be automatically computed by an optimizing engine. This language has very strong ties to the Java type system as well. So you can not only include structural steps here, but also use existing Java code. And for this purpose, we heavily rely on a really nice feature of Xtext, which is called XBase, which is an expression language. In the real world, what we see with VQL typically looks something like this. So once you really start to have the complexity in your rules, for example, involving the computation of what I call transitive closure, which is a reachability relationship along the graph, Java programmers typically write, traversals with some imperative algorithm, which is really lengthy. And in our language, these things can be expressed in a very condensed and terse way. So I've been talking about the query engine a lot. Now I will just overview the major features so you see what I mean by an optimizing engine. First of all, in VIATRA we have basically 2 fundamentally different query evaluation strategies. One of them is called the search-based engine, the other one is called the live engine. And in fact, you also have the ability to combine the properties of the 2 using advanced APIs for a third variant, which we call the hybrid engine. All of these engines share the philosophy of putting performance first, meaning that this is basically the most important concern that we've been dealing with in the past, to make sure that all the queries, even the most complex ones, even if you have very large models, run as fast as possible. In order to do this, we need to do indexing on the model. So this is again a feature of the API, which is highly reusable. So not only it's a necessity for the query evaluation engine, but you can make other uses of this as well. And based on top of these indexes, the search-based query backend can do very efficient evaluation, which is typically much faster than handwritten Java code with memory efficient characteristic. We also have a live query engine, which is a something which is not commonly found in other modeling technologies. This query engine is blazing fast, meaning that the typical response time that you get from it is always under a few milliseconds, because it constructs a deep caching network of the query results. This obviously requires some memory, but what's very interesting that you not only get very fast response time from the query engine, but you also get something which we call query result change notifications that allow you to track the changes of your model, your in-memory model, as the modifications or the commands are executed in terms of your queries, which opens up a lot of interesting applications. And finally, like I said, VIATRA also provides you a hybrid engine, meaning a very fine-grained fine-tuning ability to configure your setup depending on, optimization targets. Like I said, we put a lot of effort over the years into optimizing this engine, and a lot of benchmarking has been done. So here are the 3 most important ones that have been open source. These are all a mixture of synthetic and real-world benchmarks coming from various domains. And the common characteristics of all of these projects are that they run in an automated environment. So in fact, we do regular benchmarking and performance regression testing for each and every release of this framework to make sure that the performance keeps getting better and better. Now, just a couple of words about transformations. So I think we talked about this topic in general a lot before. Just a quick recap. So there are basically 2 major classes of model transformations, one of which I call model-to-model transformations, the other one is model-to-text. This is also frequently called code generation, and VIATRA targets both, in fact. So we have APIs, transformation APIs, tailored to the necessities and requirements of both problems. However, we approach this problem from an entirely different point of view than most transformation tools, because VIATRA, the transformation part of VIATRA is basically a rule engine, in the sense that it provides a reactive framework for organizing the control flow of model transformations in a way that they can naturally follow the evolution of a model inside the modeling tool. So in VIATRA, a model transformation is not only just a batch program, like a code generator that you run and generate code, but it can run as a daemon in the background, making sure that whenever you change something in your model or you type something into an editor, all the changes are pushed down the processing chain in order to make it possible to, for example, create an incremental code generator, which is obviously very important for scalability purposes. Just to give you an idea of how this is programmed, like I said, we rely heavily on Xtend. Obviously, you can program our APIs in Java as well, but they were designed mostly with Xtend in mind. And it's really easy. So you can reuse the query definitions in VQual and then assign code snippets or rules according to their lifecycle changes. So for example, in this case, if the engine recognizes a new match for a certain query, then it will automatically run a transformation snippet corresponding to the particular newly created model elements and do something in the background. So this is basically the fundamental idea of reactive transformations. Finally, just to overview the major features of VIATRA very quickly. So other than the query language and the Xtext-based editor, we also have a debugger and Maven tools for automatically building code, and also a test framework with the coverage analysis support, which was necessary for commercial tool engineering. About the runtime, I already talked a lot. Regarding APIs, there is a lot of easy ways to integrate your own tool with this framework. So there are a lot of standard APIs that you can use to make use of these reactive transformations and the incremental queries. And finally, on top of all of this, VIATRA also contains some larger features which we call add-ons that provide additional functionality such as view maintenance, validation framework, design space exploration, which is a multi-objective optimization tool based on model transformations, and we even have a complex event processing engine. So you might have heard about a framework called EMF InQuery. It's actually a precursor of what we call today VIATRA. So it was in 2014 that InQuery was merged into VIATRA, and from then on we've done a lot of work, mostly regarding optimizations, not only performance, but also the memory impact has been considerably reduced. And since Oxygen, VIATRA is part of the release train, which is 1.6 in our version hierarchy. The final thought is about immediate plans for the future. So we would like to extend this technology further into the domain of big query or big data by adapting it to be able to run directly over model repositories and even graph databases. And we will also start working on a new query language, which will be a usability first multi-syntax language, allowing for both single line queries like AQL or OCL, for example, but also featuring a graphical syntax for less technical users. This is my final slide. So VIATRA is done by a lot of academic contributors, and two major companies are collaborating in this, ourselves and Itemis. And we've been lucky enough over the years to find a lot of very interesting uses in a lot of different organizations. So if you are interested to learn more about this, then you should visit either the Eclipse website. We also have a lot of open source stuff over on GitHub. And finally, if you are interested in commercial support for this technology, then InQuery Labs website is the one to visit. Thank you very much for your attention.